Today we're going to look at some linear equations. So remember, linear equation has this form, right? Y equals mx plus b. This is the general form. This is also called the slope intercept form, because the m here is the slope and b here is the y-intercept. You can get different forms of a linear equation. They're all ultimately the same, but there's different ways to write it. Check this one out. Y minus y1 equals mx minus x1. Now this is another way to write a linear equation. This one, notice, it uses the slope, yeah, it uses m, but it doesn't use the y-intercept. Instead of the y-intercept, this one uses a point on the line, any point on the line. This is called a slope point form. There's one more way you can do this. It doesn't have to be y equals something. It can be in this form. Ax plus by equals some constant c. Now, if you move things around, right, this is not in the standard form. This is not in the slope intercept form, but if you subtract this, divide by b, you'll get there, okay? So these, all three of these are different ways, right, to write the same equation. If you were to plot this on Desmos, the graphing calculator, it'll give you the same exact line. They're just gonna overlap each other, okay? They all mean the exact same things. It's just different ways of writing it. And sometimes it's more convenient to write in a certain form than the other. Like we're gonna see in this question, we don't know what the slope is, you'll see. So there's a phone plan. She has a budget of $30, okay? And one call takes 20 cents, a text message takes 15 cents. How can she show how many calls and texts she can make? So now this is a real life problem, okay? We don't know what y is, we don't know what x is, so that's gonna be our first step. Step one, we're gonna assume x is something, y is something. It can be anything. Like for example, let x be calls, okay, but x can also be text messages, it doesn't matter. And then we're gonna let y be texts, okay, because there's two variables here. The bill is dependent upon how many calls she makes, how many text messages she makes. Next, we know each call costs 20 cents, so that's going to be 0.20 in terms of dollars. X, okay, so this is the money that you spend on calls. Again, this means the number of calls. X is the number of calls and y is the number of texts, individual calls and texts. And y is going to be 0.15 y, right? So again, look at this. This is the money spent on calls. This is the money spent on texts, right? The total money spent, and then we're adding them up because the bill is going to add them up. And we know her budget is $30. So there you go. That is the answer to this question. Okay, so notice how this one is not in the point form or whatever. This one is more beneficial to do it this way. Now, how do you go about graphing something when it looks like this, right? You can always subtract 0.20x and come up with the slope and the other thing, but you don't have to do that. What I'm gonna do is I'm gonna make a table of values, okay? How many points do you need to graph a linear equation? How many points? Yeah, you just need 2 points. So we're gonna find the x-intercept, we're gonna find the y-intercept. Look at this. The x-intercept is when the y value is 0, yeah? So when this is 0, we're gonna get the x-intercept. So that means it's just 0.20x equals 30, okay? 0.20x plus 0 equals 30. Therefore, the x-intercept is 30 divided by 0.2, which is 150. What does this mean? This means when the y value is 0, right? In other words, when the x-intercept, for the x-intercept, the y value is going to be 0, and you're going to get the x-intercept as 150. Similarly, to find the y-intercept, we're going to let x be 0, okay? Look at this, it's going to look like this now. We're trying to find the y-intercept, x is going to be 0. Divide both sides, I think that's going to be 200. It is, so there you go. We have 2 points, and again, we're not trying to be super precise here in terms of the graph. So 150, let's just say this is 150 on the x-intercept. Let's say this is 200 on the y-intercept, yeah? And your graph is going to look something like this. Cool?
Mm-hmm.
What's the slope of this line? Remember, slope is rise over run, right? See, this is your rise. So slope is going to be 200 with a negative sign because it's going down. That's our rise. What's our run?
150.
150. So this is going to be minus 4 over 3, right? So what a question will ask you is it's going to ask you this, and it's going to ask you to write it in the point intercept form. So we can quickly do that. So we know our slope is negative 4 over 3, x, and our y-intercept is 200. There you go. This equation here and this equation here, they both mean the exact same thing. They are both representing this straight line here. So what does that graph actually mean? So if we go in the negative x-axis, we're gonna get negative number of calls. So that's redundant, right? That's useless. So we can't have a negative number of calls. Similarly, if you go on the negative y-axis, you're gonna get a negative number of texts, which is also doesn't make sense. It's not applicable to a real life problem. So even though a graph looks like that, right? We're just gonna erase the parts that we don't need. So there you go. That would be the answer to this question. Now, what does this mean? This means, you see this line? How many points are there on this line? How many individual points are there? That's a trick question. The answer is infinite. Okay,
Mm-hmm.
there's infinite number of points on this line. So basically she can pick any point. Like for example, she can pick this point, which represents like maybe 50 on the X. And again, this is not to scale, but this could be one of the combos she can do. She can make 50 calls and 150 texts, or you can pick something here. She can make 140 calls and 20 texts, something like that, you see? So she has an infinite number of choice here, okay?
Mm-hmm.
So for these questions, these type of questions, we're gonna come up with an equation by ourselves. And it's easier than you think because every single time, almost every single time, I'm not gonna say 100% of the time, it's going to be something x plus something y equals some value. Like look at this. So there's $600, right? So we know when we add things up, it's going to be 600. He goes to, so 1 pound costs $2. So we can let X be the number of pounds, okay? That's a bad pound symbol, but there you go. We can just write this in words. So this is gonna be the number of pounds, and euros are gonna be Y. So let Y be euros. What's gonna be the equation here?
2x plus 1.5y.
Yeah, 2x plus 1.5y. Now again, notice this is the amount she spends on pounds. This is the amount that she or he spends on euros. And we're gonna add them up because it's gonna add up to 600. It has to add up to 600. Again, this very simple equation, right? And we can graph this really quickly. They want us to use a table of values, and we're gonna do that. You can always, look at this, we already know the answer to this question. You can always subtract 2x. You can always divide by 1.5. See, we can go from one form to the other by just throwing the x away and then dividing by whatever the coefficient of y is. But this one's quite difficult to graph. That's the issue with this one. This one is quite difficult to graph because if you're going all the way to 400 on the y-axis, right? You see -2, you're gonna pick this point, and then the other point that you will pick is going to be right there. You see that?
Mhm.
And it's very imprecise. Even when you're drawing a rough sketch like this could be like this could be like this could be like this, because the points are so close to each other. So for this one, the best approach to graph, even if you're making a rough sketch, would be to use a table of values, which uses the x-intercept and the y-intercept. Now for the x-intercept, the y value is going to be 0, okay? If y is 0, what's
Mhm.
x equals to in this equation?
It's 300.
It's 300, right? So that's going to be our x-intercept. Similarly, for the y-intercept, our x value is going to be 0. So this is going to be 0. 600 divided by 1.5 is 400, okay? Like that. And using this, we can graph it. Even though it's a rough sketch, but it's going to give us a very good idea. Look at this. This is what our graph looks like. What's the slope of this line? Well, it's minus 400. Yeah, we already know the answer. It's here. This is the answer, but the slope of this line, again, look at the rise. It's going to be negative 400 on the y because it's going down, and 300 on the x. So if you cancel out the zeros, it's going to be negative 4 over 3, which is the same thing as negative 2 over 1.5. Cool.
Mhm.
So this person can buy this many. Any point on this line is good. Literally any point on this line is good. That will satisfy this equation. Look at the next question. Explain why the relationship is linear. It's because it's a straight line, yeah? See, when you graph
Mhm.
it, you get a straight line. Another way to look at this is that the degree of this function, right? Degree of this function, you want to look at this equation. What's the degree of x? Degree means the power.
It's 1.
It's 1, right? So you can go the degree approach, you can go the graphical approach. What else can you say about this? That's pretty much it. There's two variables here, yeah, that are linearly dependent upon each other. Okay.
Mhm.
Parts you describe how, again, these are like communication questions. There's no right answer here. This depends on how well you can explain it in your own words. Describe how Patrick can use each representation to decide how much he can buy. So he can pick any point on this line, right? He can pick any point on this line. There's an infinite number of points that he can pick. But question to you, is X and Y, right? Again, remember, X is the number of pounds, Y is the number of euros. Is this a discrete variable or is this a continuous variable? You remember the difference between discrete and continuous? Discrete
Kind of.
is countable. Okay, discrete you can count on your fingers. Continuous is something like time or height. These are continuous variables, okay? Currency especially can be continuous, okay? It's kind of weird
Mhm.
because you can count it, but like something like this, right? 1.56. No one's sitting there counting pennies. It is a continuous variable. Yeah, that's basically what they said as well. Degree and the graph is linear. Let's look at another one. Okay, so there's two positions that Judy can take The first store, Sam's, offers $1,600 a month plus 2.5% on commissions. Okay, now we're talking about her combined wages. So the wage, right, how it works is you get a base pay. Okay, this doesn't happen in every job. This happens a lot in sales type of jobs, like retail, or if you've ever walked into Best Buy or, like the mobile phone stores,
Mm-hmm.
they have a base pay. And on top of this, that's why they're like so clingy. They want you to buy stuff because their wage is dependent upon the commission. So they get a chunk of how much sales they make. Okay, so it's two piece here. So the first store has 1,600 a month plus 2.5 on commissions. The other one has 1,000 a month plus 5% on commissions. In the past, Judy had about 15,000 in sales each month. Okay, it represents Sam's offer, so Judy can check what her monthly pay would be. What do you think the equation is for Sam's store, which is the first store up there? Actually, first let's define our variables. What is X and what is Y? What do you think? The hint is right here. If you just look at this, so Y is gonna be her total wage, okay? See this? This is
Mm-hmm.
Y. And your X will be this, because the wage is dependent upon the sales. Everything is gonna be constant, okay? The wage is dependent upon, the only variable there is sales. So let Y be the wage, okay? Y is the wage, and X is the amount of sales, how much they can sell. So using this idea, what is the thingamajig, the equation for Sam's store? It's going to be in this form. Look at this. Y, yeah, that's the wage. The base pay for Sam's store is 1,600. The commission is going to be 2.5% as a decimal. It's 0.025 times X, like that. Cool.
Mm-hmm.
So part A says, what is her wage gonna be? What's her monthly pay going to be? We know she does 15,000 in sales each month. So this is going to be her wage for Sam's store is gonna be 1,600 plus 0.025 times the sales, like that. So 1,600 plus 0.025 times 15,000. The answer is 1975. What's the equation for the other store, for the Carol's store? It's going to be extremely similar.
Y equals 1,000 plus 0.05x.
Yeah, 1,000 plus 0.05x. Now let's see how much she would make. The thing about commission jobs is that sometimes you're gonna have a great month, okay? And sometimes you're gonna have a not so great month. So ideally, I don't know. I think it's okay, right? As a job, it's okay, but you have the highest of highs, and sometimes you're gonna have the lowest of lows. That's why it's a little bit, you need to commit basically. That's the issue with commission-based jobs. So this is what her wage is gonna come out to be. Times 15,000, that is 1,750. So which one is better, Sam's or Carol's for her? Sam's is better, right? Because it pays $225 more. So there you go. Here, I want to show you something else here. What does this all actually mean? Again, X and Y will not be negative, okay? Sales cannot be negative, so we're going to ignore the three quadrants there. We're only interested in quadrant one. The first equation, this one, has a y-intercept. Again, this is an extremely rough sketch. Has a y-intercept of 1,600, yeah? and the slope is 0.025. So let's say this is another point on that line. So there you go. This is Sam's. Okay, this is Sam's. The other store, Carol's, has a y-intercept of 1000, which is going to be lower, right? But it has a higher slope. Remember, the higher the slope, the more vertical the line is. This has a higher slope than this, okay? The higher the slope, the more vertical the line is. So for this guy, the next point may be somewhere here, okay? All it has to be is a little bit more steeper in the vertical direction than Sam's. This is Carol's store. Notice they meet right here. What does that point represent? That's the POI, okay? That's the POI where they meet, or where the two lines meet. Question to you is, what does that point represent? Remember, on the x-axis, we have sales. On the y-axis, we have her monthly pay.
When the wage is the same.
Yeah, when the wages is the same, okay? So there comes a point for both stores where whatever this is, right? We can quickly find that by just doing this equals this. Let's just find that point. Again, I'm just setting two equations equals to one another. So it's going to be 600 divided by 0.025. Divided by 10. So 24,000. So if she does $24,000 in sales, yeah, then both of them are going to be equal. It doesn't matter which job she goes with. If she does less than 24, then we were looking at this line here, right? Because all the sales value. Actually, we're looking at both lines, but if she does less than 24,000, which one should she go with? The green one or the blue one if she does less than 24,000? Go with, yeah, the green one because it pays more, right? So less than 24,000, green one's good. More than 24,000, blue one's good, which is Carol's, and at exactly 24,000, they are equal, okay? But she does like 15,000-ish. We know for 15,000, Sam's is better, which we knew that before because 15,000 is somewhere there, and here Sam's is better than Carol's. You know, most of these questions are going to be the same. I'm looking at some interesting questions here. Okay, so this person earns $1,200 a month, and the commission rate is 3.5%. Create an equation. What's the equation? Super simple question.
Y equals 1200x plus 0.035.
Think about it again, okay? It's not going to be 1200x, and this person's going to make a lot of money if it's going to be 1200x. It's going to be 1200 plus 0.035x. Remember, it works like this, right? Wage is going to be equal to some base pay. The base pay is constant. That's your y-intercept, but it's dependent upon the variables, which is your sales. Okay, you see this is your variable, and this is the commission rate. So that's the equation. Super simple. Last month, she had 96,000 in sales. Okay, so let's see if that is what it is. So how much money is she gonna make if she has 96,000 in sales? So we're just gonna plug the X value as 96,000. 96,174. And we got 4566.09, right? So that means this is good. She's not being scammed by her employer. Okay. So here, look at this. This is not a math question, but what does this mean? Before deductions, what's going on here? What does that mean? What are we deducting? Why is that word even there? So what happens is, you see this? This is the money that she earned this month, yeah?
Mm-hmm.
A portion of this, I don't know what the rate in Saskatchewan is, but a portion of this is gonna go for income tax. So it's usually 13% is gone. So let's kill that off. So if 13% is gone, then we're gonna multiply this by 0.87. 4566.09 times 0.87. So this is what it becomes. This is after income tax. Okay. And furthermore, a portion of this, look at this, there's multiple things involved here. A portion of this more is going to go for something called employment insurance. This is Canada-wide. So you pay a certain amount each month. It's not that much. It's like 2% of your income, so that in the future, if you get laid off, right, or if the company closes or something like that, the government will pay you this money for a certain amount of time. You have to be looking for jobs and whatnot. So a certain amount of money is going to go for your insurance. And furthermore, a certain amount of it is going to go, again, this is dependent on provinces, it's going to go to your pension plan. So this is for when you retire, okay? A certain amount is going to go in there as well. So that's what they mean by deductions. Whatever you're supposed to take, right? You see this? No one takes this. You lose, see, we've already lost so much. You lose around like 700 maybe out of this, and that's going to be your take home pay, okay?
Mm-hmm.
So this happens with every single jobs. You're gonna give away a portion of your income every month. So let's move on to another question here. Let's look at this one. All right, what's going on here? So this lady pays a $350 registration fee and $85 monthly fee. Which one is the constant and which one is the variable here?
The constant is the registration fee.
Yeah, so that's a constant. You have to pay this regardless. And your variable here is X, the number of months, okay, that you go to the gym for. So there's another club. Okay, so this is club A, I guess. And let's say this is club B. The fees for club B it says it has a higher registration fee, but a lower monthly fee. Okay, so we don't know what that is. Let's say the registration fee is B and the monthly fee, let's say, is, again, that's your slope, it's M. Okay, there you go. That's the equation for the next club. After 5 months, both Maureen and Leah have paid the same amount of money. See this? 775. Both of them have paid the same amount of money. It's asking us what is B, the registration fee at the other club, and what's M, which is going to be the monthly fee at the other club. Now this one is a little bit tricky, right? Because we have a bunch of unknowns. How do you think we approach this question? It's tricky for sure. Here, let me just draw you a graph, because the answer is going to be, because T's for thinking. There's multiple ways to approach this kind of questions. You're going to see something like A, this is application. There's probably only one way to do this. You're going to see something like this K/U, which means knowledge/understanding. Probably only one way to do this, but thinking, and then you're going to get another communication, multiple ways to approach the question. So here, I'm going to draw a graph for club A. So let's say the y-intercept is 350. and the slope is 85. So somewhere here. So that's our first month, and this value there will be 435. That point there is 1 comma 435. Okay, the slope. I'm gonna connect these two dots, and there you go. That is the graph for club A. Okay, now look at this. We know there's another line. It's gonna meet this line when the Y value, or when the club fee is 775. You see right there? So we know this one has a high registration fee. Okay, cool. So let's say the registration fee is somewhere here. We don't know what that is, but it has a lower monthly fee. That means the slope, right? This is going to be less vertical. Smaller slope means it's going to be more horizontal. So it cannot be something like this that's steeper than the green line. It has to be something like this. See that? So what does that mean for us? After 5 months. So we know that the value here is 5, yeah? For 5 months they meet, so that means this equation here, the x value is 5. It's asking us, what are the possible, this value here, okay? And not that value. We know what that is. Like this value here, this intercept is unknown. We don't know what this is. And this slope here, rise over run, okay? Now look at this. The formula for slope is what? Rise, right? So we're trying to find the rise from here to here. Let's say that is B divided by run. Yeah? Rise over run is the formula for slope. So we're gonna plug this in here. See M? We're gonna plug that in there, and that is gonna give us the answer for B. This is definitely a tricky question, actually, it turns out. So we're gonna plug that in. So B stays B, plus M is gonna become 775 minus B, rise, divided by run, equals 775. So now we have a linear equation. How do we solve this for B? It's a linear equation. You're gonna take the LCD. Step 1. 5 and the denominator here is 1. So we're gonna multiply this by 5 on the top and 5 on the bottom, which means we can combine them like this. What do we do next?
You multiply by 5.
Yeah, you multiply both sides by 5. So on the other side, you're gonna get 775 times 5, which is 3875. And on this side, you get 4B plus 775. So B is gonna be 3875 divided by 775, which means B is 5, okay? And then you wanna plug this back in here to solve for M. So 5 plus 5M equals 775, which means 5M is 770. 770 divided by 5. So the other answer there is 154. Cool? So this one was definitely a tricky question. Let's look at another one which may not be as tricky as that one. See, A's application, there's only one way to do this. Ben's bikes. Okay, so you're renting two things. You're renting racing bikes for $25 a day. So we're gonna say racing bikes, the number of them is X, and then the mountain bikes, the number of them is Y. What's the equation here?
Y is 3450.
That's going to be something x plus something y equals 3450.
25x plus 30y.
Yeah. 25x plus 30y is going to be equals to 3450, like that. Now we're just going to make a sketch here by putting in x and y. Again, remember, well, for the x-intercept, the y value is going to be 0. So 3450 divided by 25 is 138. That's our x-intercept. For the y-intercept, the other guy is going to be 0, which gives us 115. So this is what we have. On the x-axis, we have the racing bikes. On the y-axis, we have the mountain bikes. And your sketch is going to look like 138 here, 115 here. It's going to look like this. What's the slope of this line?
115 over 138.
Yeah, it's going to be negative 115 over 138. That's the slope, which means the equation in the slope-intercept form will be y equals m x, and we know our b value. B value is the y-intercept, 115, okay? It says, look at the questions now. It says, determine the greatest number of racing bikes that could have been rented. What's the highest number of racing bikes that could have been rented? The answer is right there in the graph. Or right there in the table as well. It is the x-intercept, 138. What this means is you can rent 138 racing bikes and no mountain bikes. Okay, greatest number means the other guy. Look at this equation. Greatest number means we were trying to maximize this. So that means we're going to minimize this. And the minimum y value is going to be 0. You rent no mountain bikes at all. So it's going to be 138. What about B? Determine the greatest number of mountain bikes that could have been rented.
It's 115.
Yeah, it's 115. C, we've already done C, right? When you start working with these questions, they're usually going to ask you for an equation or a graph, which we already have right here. So you can do any amount of things here. Question to you, is x and y in this question a discrete variable or is it a continuous variable?
Discrete.
Yeah, because bikes, the number of bikes cannot be in decimals, right? It has to be countable. Okay, let's look at this question. This is how you know this book is pretty old. It's still used to this day, but you're talking about MP3 players. You know what this is? This was before the age of phones, right? Cell phones. You'd have this little device. It's actually pretty, it's the size of like maybe like a big eraser. And then you could put songs in here and you'd listen to them. This was before cell phones. And after cell phone came out, well, there was no need for this. That's why this died out. So this was an MP3 player. The evolution of an MP3 player is an MP4 player. This one only plays audio, okay, exclusively for music. MP4 was a little bit bigger, came with like a screen, like an older iPod or something. This one plays both audio and it also plays video. So that was an MP4 player. Once cell phones came out, both of these became redundant, so we don't see them these days. But anyways, here, there's an MP3 player that charges $9.95 per month plus 0.55 for each song. He has a budget of $40. Determine the maximum number of songs that he can download. All right, what's the equation here?
Um, 40 equals 9.95 plus 0.55x.
Yeah. So This is constant plus 0.55x. This is the equation where y represents his budget. In this case, his budget is $40. So like that. And then this is just an equation, right? We can quickly find what x is. 40 minus 9.95 divided by 0.55. X is not a whole number, 54.63. So that means he can afford 54 songs. Okay.
Mhm.
That's it for that question. And let me tell you, no one was paying for individual songs when these things were around. So at 9, this one looks to be a tricky question. This guy is living, he left Windsor with 64 liters of gas. He drove east at 100 kilometers per hour. The low fuel warning came when 10 liters of gas were left. And it uses gas at the rate of this. When did the warning light come on? All right. This one is a tricky question, and the answer is right here. What does X represent? And what does Y represent? If you can figure this out, you can write an equation really easily. What do you think X and Y is in this case? Y is the amount of fuel left. Okay.
Is X hours?
You see this? What does rate mean? Mathematical, what does it mean? Rate of.
Mm-hmm.
Rate is the slope. Okay, see the answer is right there. You can kind of work backwards, you know, if you know, because this is the key word here, rate. This makes things a lot easier. You see rate? That's our slope right there. M is 8.8. And again, look at the units on rise, right? Liters per 100 kilometers. This is our Y, okay, which is the fuel left in his gas. And this is our X. It is the kilometers he's driven, okay?
Mm-hmm.
All right, so using this information, okay, what is our equation here? Y equals what? Again, remember, Y is the fuel left, right? What's the intercept? How much fuel was there in the beginning?
64 liters.
64, right? Does the fuel amount go up or down?
Down.
Down. That's why minus, okay? That's our intercept, 64 minus because the fuel goes down. And we know what our slope is, 8.8 x. Cool?
Mm-hmm.
Now using this, that's our equation. We're gonna find out what x is. When the y value is 10, which is the fuel left, we're gonna figure out what the x value is. So this will be negative 54 equals negative 8.8x. So negative 54 divided by 8.8. The answer is x equals negative, it's not negative, sorry, 6.136. Cool? X is in terms of 100 kilometers. Every 100 kilometers, that means this x is 613.6 kilometers, okay? After he drove for 613 kilometers, the thing came on. But now this question is asking us for the time, yeah?
Mm-hmm.
It's asking us for the time. So for him to use up 613.6 kilometers, right? This is our distance traveled. Our speed, our velocity is 100 kilometers per hour. How long did it take? We need to find the time, right? Now look at this. Distance, speed, and time are related. Distance is speed times time, okay? Which means
Mhm.
time is distance divided by speed. So using this, we can find the time, which is right here. Or you can do that again. 613.6 divided by 800. Time has passed is 1.163 hours have passed. What is that in minutes? It's going to be 6 hours. What is that in minutes? It's going to be 0.136 times 60. So 0.136 times 60, that's going to be 8.16 minutes. So you have 6 hours, 8 minutes, and 0.16 times 60 is 9 seconds. There you go. So he started at 9:20. The amount of time that has passed is 6 hours and 8 minutes, right? So you add it
Mhm.
up, 28, 15. 15 means what in terms of time? Three o'clock, yeah? In the 24-hour system, because 12 o'clock is 12, 13 means it's 1, 14 means it's 2, 15 means it's 3 o'clock. So at 3:28 p.m., the warning light must have come off. Okay.
Mhm.
So this one was another tricky question. 3:28. How did they do it? They did the exact same thing. Again, this one is more of an application question. There is only one way to do this. Okay. Only one way to do
Mhm.
this. If you can't figure out that this is your slope, then you're going to have a rough time because there's a bunch of numbers here. If you put this as your slope, then you're done. You can't do it right. Let's do another question here. The K there is for knowledge, which means it's not a tricky question. It's straightforward. So on the x-axis, we have the number of people. On the y-axis, we have the cost. Locate the point this point 160. So look at this. 160 is between 150 and 200, right? So that means the middle line here is 175. 160 is going to be slightly to the left of. So maybe somewhere there is 160. So that's 175. This is 162.5. So somewhere here. Again, this is not going to be precise because the scale is in the thousands. What did this coordinates tell you about the chart? So what does that point represent? You see this point here, 160, 5700. What does that represent? It means if 160 people show up, right? The charges is gonna be $5,700. Cool?
Mhm.
That's it. If 160 people show up to this event, then the bill is gonna be $5,700. The next question, what is the charge if 200 people show up? And this is a very simple question. You just read off the graph. 200 is a nice point. So 200 people show up. Look at this. What's the charge?
7,000.
7,000. This tells us our slope, right? What's our slope? Using this point, we can figure out the slope.
7,000 over 200.
Yes, 7,000 over 200. This cancels this out. 70 over 2 is 35. And our y-intercept, what does our y-intercept appear to be here?
500.
500 exactly. And using this, we can write our equation. So 500 plus 35x. What does this 35 represent? What does it mean in words? If it asked you to explain what the slope means in this context. It means this hall, okay, charges $35 per person. Because if you think about what $35 is, the answer is always in the units. Look at this. On the rise over run, the unit for rise is dollars. The unit for run is the number of people, right?
Mm-hmm.
So what this means is that you pay $35 for each single person. What does the 500 they represent? The y-intercept.
The starting cost.
Yeah, exactly. That's the base fee. So even if no one shows up, you're still down $500, okay? That's the constant.
Mhm.
That's like the registration fee we saw in the gym question. It's the base fee that you have to pay no matter what. Part D, using your equation, determine how many people can attend for this. Again, you just put this as y, solve for x. We're gonna ignore this question. E is more important. Why is a broken line used for this graph? Where's the broken line? I think it means the dotted line. Any ideas why? Right? Did I pull up the right graph? There's only one graph here. A broken line. I think it's talking about the dotted line for sure. It's because you see these points here.
Mm-hmm.
What is that point? Who knows? We know this on the x, but we don't know what that is on the y. You see that? We know this one on the x, we don't know what that is on the y. We don't know precisely. This one's even worse. Like, what is that y value there? That's why. Because we're not sure what the points are. Cool?
Mm-hmm.
Here, let's look at this question again. This one's kind of tricky, right? The time one. Again, remember this rate. What does rate mean in terms of linear equations?
It gives you the slope.
Exactly, it gives you the slope. So look at this question. Y is the fuel left, okay? Y is the fuel left, and X is in terms of 100 kilometers. X represents kilometers. So our equation here, very simple. Look at this. 35 is our intercept, right? The initial fuel value. Our slope is 9.5 x. Cool.
Mm-hmm.
Okay, so the low fuel warning came when 9 liters was left. Is this y or x?
It's y.
It's y. So using this, we're gonna find what our x value is. Like that. So 9 minus 35 divided by 9.5. So the x value is 2.737. Okay.
Mm-hmm.
So that means this individual traveled, again, x is in terms of 100 kilometers. So the distance he traveled or she traveled is 273.7 kilometers. This is your D. The speed is 100 kilometers per hour. How do we find time when we have distance and speed? Time is distance divided by speed, okay? You can use logic as
Mhm.
well. Let's say you traveled 100 kilometers. It took you, and your speed is 50 kilometers per hour. How long did it take you? 2 hours, right?
Uh-huh.
You traveled 100 at a rate of 50 kilometers per hour, so it took you 2 hours. Same thing here. You just divide them straight up. Distance, I can remember this. This is more like a physics idea, but it's common sense as well. Time is gonna be distance divided by speed. If you do this, you're gonna get this exact number, 2.737 hours. Okay.
Mhm.
Now, what is 2.737 hours in terms of minutes? Look at this. This is 2 hours plus, you're gonna take the decimal point there, and to go from hours to minutes, you multiply that by 60, like that. You do this, you get 2 hours and 0.737 times 60 is 44.22 minutes. Now this 0.22, you can convert that into seconds if you'd like by multiplying that by 60. So you get 2 hours, 44 minutes, and the 0.22, just multiply that by 60, you'll get 13 seconds. There you go. That's how much time has passed. So when did she leave? She left at 2:15. We're adding 2 hours and 44 minutes, 9:59, 4:59. The light came up at 4:59. Cool?
Mhm.
Before I let you go, I'm gonna ask you a question here. Let's say we're adding 2:15 with 2:46. In other words, we started at 2:15 and this is the amount of time. After 2 hours 46, what's the final time? Again, just add them up. 5 plus 6 is 1, yeah?
Mhm.
So it's 11, so it's gonna give 1 to this guy. 1 plus 4
61.
is 61, right? 461, but that doesn't make sense.
Mhm.
So what you do is 4 hours and, or sorry, 4:61 p.m., right? 4:61 p.m. You're gonna change this 61 into an extra hour here. So it becomes 5, and how many minutes are left? Oh, 1
One.
p.m. There you go. Okay, that's how you'd add
Mhm.
time when the numbers are bigger than 60. All right, let's call it a day there.
Okay, thank you.
See ya.